Morning, everyone. Thank you for being here. It's fourth day of reInvent. Hope you guys are having a nice time. And today we are going to be talking about Angry Birds and how they're using GenAI. So how many of you are trying to integrate AI into your GenAI process, or you're trying to integrate AI into your game development process? Are you finding it difficult to balance creative control with production efficiency? Nice. So my name is Rupar, and I'm working as a senior account manager at AWS, and I've been supporting gaming customers for the last 3 years. And I have the pleasure to be joined on the stage with Ignacio, who's working as a principal ML engineer at Rovio, and he's been working on building the exact same capability for them. We are going to be diving deep into real examples of some of the most popular games of Rovio, and how are they using GenAI to accelerate their asset creation, and at the same time, protecting their brand unique identity. We are also going to be talking about how you could use tools like Amazon Bedrock and Amazon SageMaker to make these things work for you and your game development process, basically to help you revolutionize your game development process. All right. But before we dive into the topic, let me quickly paint a picture of Rovio for all of you. So I think most of us know Rovio for Angry Birds, right? But there's just so much more to the story. So Rovio is a Finnish gaming studio that accidentally created a global phenomenon when they launched their 50-second game. That's right. It was their 50-second attempt to build Angry Birds. And today, it's loved and cherished by all of us. Today, Rovio is not just about flinging birds at pigs, though they are still pretty good at that. It's much more than that. Rovio is a modern entertainment company. It's a game-first entertainment company who's pushing boundaries in movies, animations, gaming, and now AI. Talking about that, let me quickly tell you a story about how they stumbled upon AI. Next slide. All right, so picture this. On one side of Rovio, we had the tech wizards, the ML team. Ignacio is standing at the right side. And on the other side, we had the creative souls of Rovio, the artists. They nearly made 1/3 of the workforce, but they were drowning in deadlines. Why? Because they were not able to create assets and art at the rate which the people playing the games were devouring it. So that was a big challenge. Imagine that for each new season, Halloween, they need spooky birds. Valentine's, they want all the birds and pigs to look lovely. Christmas, bring the Santa hat for everyone. And that's just different seasons. Imagine new game features, more art needed, special events, more art needed, and that's just making the life of an artist and their pipeline very daunting, and that's what they were facing. So here's the real challenge. While the artists were trying to focus on building new art and new assets, they were doing repetitive tasks, like creating multiple variations of the same background, or doing some incremental changes in the existing assets. And that is something that they were not looking to do. That is not something that they were passionate about. Then came the aha moment. And that is where the ML team came up with an idea. They were diving deep into GenAI capabilities, and they realized something. What if they could give creative superpowers? What if they could turn some of the tasks of the artists that would take days, in some cases, into an hour's job? The numbers were compelling. For a specific use case that we are going to talk about today, which is a season pass background, they could save production time by 80%. So 80% savings in production time. And that's not just savings. That's a game changer. It was like discovering a new power-up in their own game. The ML team had the technology, and the artists had the experience and the creative expertise and massive amounts of unique Angry Birds data. Together, they could create something neither of them could have achieved alone. And that's where their AWS journey begins. I would now like to invite Ignacio to throw some more light on the journey.
So let's go back to 2022. As Rupert mentioned, the ML team and the art team were not working together back then. But what happened then was that diffusion models came out. In 2022, we started seeing a lot of image generation models that could generate really good images, and we wanted to try those with our brands, with our Angry Birds. But before trying anything, what we did was to set some ground rules. We wanted to always use our own proprietary material. We also wanted to keep our data safe. That's why we did only things locally or on our cloud. And also we wanted to respect everyone's intellectual property, even in prompts. So with those ground rules, we went and tried the tools, but they didn't work so well with our brand characters, with our Angry Birds. So what we did was we wanted to explore these tools, but we wanted to build something ourselves. So we started a proof of concept, but in 2022, where the goal was to learn and try to explore this area to find our own journey and our own way to work with generative AI art tools. So we did a proof of concept, and the goal of this proof of concept was to start training a model of Red, the Angry Bird, our main character, in the style of our movies. Here you can see one of the first datasets that we put together. They contain a lot of images of Red on the style we want to generate. And guess what? We failed. It didn't work out so great. We failed in all possible ways. Here you can see some images from the first generation we got, trying to fine-tune a model to generate Red riding a bike. And we kept trying, and we kept failing again and again. We got a bit better. Now, some of the pictures of Red, the Angry Bird, are a bit more recognizable on the style of the movie, but still, they are a bit scary, some of them. But eventually, after trying a lot, we learned how to do it. Here you can see some images generated from the model we got back in December 2022, in the style of Red from the movie. And now I want to ask you a question. What do you think about these images? Please raise your hand if you think these results are good. Okay, I see some hands up, maybe not many. I have to say that back then in 2022, I was super proud of this model. It was way better than what you could achieve back then with any out-of-the-box tool. But when we showed it to our artists, they didn't agree with me. This was not good enough. You can see in some of the gestures of Red, it looks a bit creepy and a bit awkward. So this is not up to the standards of quality that our artists expect. But why is it so hard to generate Red? So one of the main reasons is that all of these are Red. You can see on one side the classic version of Red, and in the middle the Red from the movie. They look very different, but they are all recognizable by our fans. Everyone knows this is Red. So that's why the models were struggling a bit to generate Red, because we have many different versions of them. For example, here you can see some of our Angry Birds in one of our best games, Angry Birds Dream Blast. They are cute baby versions of the Angry Birds. They also have hands and legs, while in Angry Birds Friends, in this spooky pirate ship, they are a most classic version of Red. They don't have any legs, for example. And here you can see them in the style of Angry Birds 2, a bit more modern look of the classic Red. So, even though we failed, we kept trying. So we, in 2024, trained a model using the style of our game Angry Birds Dream Blast. You can see on this side that we have the target style. That's an image that has been generated by our artists. And we can see in the other side some AI generations from the model we fine-tuned. And I want you to ask you again the same question I asked before. What do you think now about these results? Please raise your hand if you think these are good. Okay, I can see more hands raised up. I raised it myself. I think these results are really good. But when we ask our artists, about these results, we showed them these pictures, they found a lot of defects that I could not even see. Because pretty good is not good enough. We have hundreds of pages in slides explaining how you should draw our Angry Birds. For example, the eyes. How you should do the eyebrows and the cheeks to create expressions in our Angry Birds. Also the wings. And even the feet. We also have decks explaining how you should draw the different facial expressions to express happiness, anger, or surprise in our characters like Red. And we have this for all our different brand characters, our main characters. Because it's really important to us. Our artist has really high quality standards because it's our brand and we don't want to mess it up. And AI should help us raise the bar, not lower it. But even though we failed, our artists were not satisfied with these results, Red showed us the way. We learned a lot along the way doing these failed experiments, and I'm going to show you now some of those insights we got from there. One of the first breakthroughs we had was that even though we had trained a lot of models with Red that didn't work out, we could use those same models to generate secondary characters. And why that worked is that we didn't have hundreds of pages of slides explaining how you should draw them. So there was not so many guidances explaining how you should draw the eyes, the wings. So this was one of the first things we discovered. You can see here the picture of a cute baby crocodile and shark in the style of our game that we could use for different purposes. We also learned that it made sense to focus on non-brand essential assets. As Rupert mentioned before, some of the tasks of our artists were a bit repetitive and boring, like, for example, creating multiple variations of a background. So if we start doing AI for those tasks, then the artists have more time to spend in things where they can create the most impact with these characters, emotions, and a story. But even though we found some use cases, like secondary characters and backgrounds, there were a lot of challenges. The first one was about control. It was really hard when the artists used these tools the first time to get the results they wanted, especially if they were focusing on generating Angry Bird characters, which was not the right use case. They got frustrated, so they tried once and they quit. And even if you're focusing in the right use case, it takes a lot of practice to master these tools. But we also learned that AI is better for things where you don't require exact control. Like, for example, creating new locations and backgrounds. Because in these ones, we can be more flexible about the style. If we generate an Angry Bird out of proportion or with a third eye, that's not good. But in a background, we can have a second tree, third tree, another rock here, and that's OK. We can be way more flexible, the same as with secondary characters. Second challenge was about volume. We needed to generate hundreds of images just to get a few good ones. So we needed to learn a certain level of randomness when working with these tools. Sometimes you have an idea in your head and you want that exact same thing being generated. So the artists needed to learn, and also we needed to learn to be more flexible there. You needed to learn how to be surprised by the AI generations. And each generation takes a different seed, but we also learned that you can lock the seed and modify the prompt to only modify some parts of the images. The image still changes, but you can have a bit more control, which addresses the first challenge we had, which was about control. And the third challenge we had was that we didn't want any generic image or a style. The models that are out there, the base models, they generate really good realistic images, but they are not on our Rovio style. So we really want to generate things in our style. So what we learned is that we needed to assemble a really high, good quality data set. And it doesn't take so many images, just 30, 20 images is good enough as long as they are well crafted by an artist. In the first proof of concept I showed you from Red, The ML engineer team was the one gathering those images and caption them. But we learned that if you have an artist that captions these images, it's way better. They will also comprise the style they want to generate in a few images better than ML engineers can do. They also have way more rich language to put the prompts, explaining what's in the image. And also, at the end of the day, the artists are the one using our tools. So also, the captions will be closer to what they will be prompting. And even more important, it also creates a lot of trust, because they are part of the fine-tuned models we are training. So when they change some images in this data set, they can see how it impacts on the results. And that builds trust. So by crafting these good data sets, you can generate images in our style like these ones. These are unedited outputs coming out of the AI when you use that data set for fine-tuning the model. So we learned that we don't need to be flexible with the style as long as we lock it really well with the data set. But the biggest learning of it all was that it takes an artist to use this tech and an artist to review the outputs. It takes an artist that has a really deep level of understanding of what makes visuals work. It takes an artist that also has a rich vocabulary to explain what's on the image to create those captions. And it takes an artist that also can then review the outputs to make sure that they have a high quality that we want, and also make the necessary edits to reach that quality when needed. Okay, but you may be wondering, how does it work? So don't worry, I will try to keep it simple and brief. 3 main steps. First, pick your base model. There are many, no silver bullet here. Ones work better for your one use case than for others. Second, fine-tune your model, as I mentioned before, creating one good data set with your artists. And the third step is to build a workflow. When artists generate images, they don't usually interact directly with the model. They use workflows, which are a set of steps where they can turn an idea into a final image generated. And they can have inputs like the prompt, but not only. They can also modify, for example, the number of steps, and many more things. They could also in-paint on the image to only modify one part of the image. So these workflows give them more control. And we need to build those workflows from those fine-tuned models we have trained. But this is maybe a bit high level, so let me dig a bit deeper. Let's start with the base models. How are these trained? We have them trained with billions of images from the internet with some text descriptions associated. Here you can see one example of a cat in a living room. And those captions are transformed into embeddings, which is a representation on a high-dimensional vector space that gets into a neural network. But we also put the images into a neural network, but not the original image. We destroy the image, adding noise, and transform it into latents. Latents is a more abstract representation on the image, capturing the main information. So the neural network gets as input both the latents and the embeddings. And it learns how to revert that noise, guided by the text that it gets from the embeddings. So, in a nutshell, these diffusion models are all about adding noise and removing noise. But these are just the base models. They generate generic art, not Rovio art. So we need to fine-tune them. And as I mentioned before, it all starts with a good data set that captures the style. So the base model can have this new concept from our data set on top added. Then we also need a trigger word. This is a word that will capture our style. It's that word there on the top in red. And you can notice it's a very weird word. And the reason of that is that we don't want it to conflict with the dictionary that it already exists in the base model. So we have, same as before, the latents and the embeddings going into the neural network. And then we decode them, those latents, and generate an image. In the first step of this fine-tuning process, the image looks really realistic, as you can see in the picture. But in each of the steps, it will start looking more and more similar to the style from our dataset. And behind all this, we have the images stored in S3, and all these fine-tuned trainings happen in SageMaker training jobs. So we can run dozens of trainings in parallel. and get the results in a couple of hours. Why we need dozens of trainings? As you can imagine, if you have worked with machine learning, the first training is not always the best one. You have a bunch of hyperparameters like learning rate and the usual suspects, but also we have a lot of versions of the datasets, different ways to caption that we need to experiment with. So that's why we need a lot of trainings, and that's where SageMaker training just comes really handy. And let's see one training in action. You can see how the images start looking more and more similar to our style. And at some point, it starts to overfit. So the later step is not always the best one. So one challenge is, how do we decide which model to pick? Because in each of these steps, we have in S3 a safe tensor file, which is the model artifact that then our artists will use to generate the images. So what we do is we show these videos to our artists, and they decide. So OK, we have fine-tuned our model, and the artists have decided what's the best one from the previous video. So then we take this safe tensor artifact from S3, and we put it into tools or workflows so they can generate images. This is one example. Imagine one of our artists wants to generate a northern lights in their style. So during inference, these models start from random noise. But after several steps, it will start looking more and more similar to the style you trained it with. And at some point, it will look like this, northern lights in the style of our game. But as we may mention before, we don't use the model by itself, we use workflows. So in these workflows, we can fine-tune and tweak a lot of different things, like, for example, the steps. If you pick a lower number of steps, the image generation will be quite fast in just very few seconds. But it will also be not so high quality. So for experimentation, it's always good maybe to start tweaking the prompt and having a low number of steps to be faster. We also have things like model strength, how much you want your generated images to look like your style. You can even combine two different fine-tuned models to combine two styles. We also have a guidance scale that tells you how much the AI should follow the prompt. So if you pick the right value there, you can let the AI be more creative. And all this is powered by EC2 G6E instances, which makes this generation happen in seconds. So our artists don't get frustrated because they don't have to wait. But, OK, we have images in our style, but we need to turn them into game assets. That's where the value is. So this is how our pipeline for our artists look like. We put the artist on the center of it all, because as I mentioned before, we want them to be the ones in control. And the first thing they have to do is to come up with an idea and find a way to prompt it. For example, imagine they want a machine to generate rainbows. So they generate a bunch of images using our AI tools, and then they pick the best one, the one they like the most, as a starting point. And then they still need to do a bunch of stuff. They need to clean the image. There may be some weird artifacts there. They need to expand it. They also need to upscale it because these AI models generate images in lower resolution. It's also faster if you use lower resolution to generate them. And at the end, they also need to create different layers and put our brand characters, our Angry Birds on top, to create the story they want to tell and embed that into our game UI. So you can see at the end that we turn images generated by AI into our games. And that's how we could generate season pass content way faster than we could before. For those of you that are not familiar with mobile games, season pass content is a limited special event that we run. Usually it takes a month. And the players can experience new content, seasonal, and earn rewards. For example, right now, it's Christmas time soon, so most of the games are going to be releasing some Christmas season pass. And it takes a long time to generate all the assets for the artist to generate all these images. So that's why using AI, they could speed up the process to generate some backgrounds, and then they will still be in control of generating the characters and putting them on top. But the process became much faster. It went from just taking weeks to days. But they were still in control. And another thing to mention is this is not only about the AI, it's also about changing the way they worked. Because the first time they tried generating images with AI, they had a brainstorming session. And then they decided what they were going to do. And then they went and generated the images. But then they had a clear idea of what they wanted to generate. And as I mentioned before, you need to learn how to be surprised by AI. So it didn't take so few days. It actually took almost the same time, that first iteration, as it takes generating this without AI. But in the second iteration, what they did was, they did first the image generations. They generated a bunch of images, and then they ran the brainstorming session afterwards. And that helped speed up the process a lot. So it's not only about AI, it's also about changing the process of how this content is created. And you can see here in fast motion how the artists edit these images and put them together into the final result. So this is basically a couple days them editing the images and creating the story. But how are artists use our tools? Because at Rovio, every artist thinks differently about AI. Some people loved it at the beginning, others found it confusing. Some, they didn't even want to try it. Some got disappointed because it was not one click. They just wanted to generate one image and be perfect one. But others got disappointed. They didn't want to try it because they thought it was one click. They were really used to really complicated tooling. They really that gave them a lot of control, so they wanted that complexity. Some people at Rovio, like myself, ML engineers, we like to generate the images using Python, but the artists are not that technical. They may prefer creating prompts like this to explain what they want to generate. They have the vocabulary to create prompts like this, explaining the lighting, the camera angle, the characters. But it's not for everyone, and this is not even the longest one, it's just the one that could fit in the screen. And so not everyone enjoys writing this. Also, these flowchart tools that we call workflows are very complicated. So not everyone enjoyed that, but some did. So our goal was clear. We had to give the right tool to the right people. So that's why we built multiple tools, powered by AWS. And we call them Beacon Pegaso. So I'm going to explain now about this, but before that, I want to say that I don't work in a game team. I work in Beacon, which is a central unit that provides games as a service, as a platform for our games. So basically, making games can be science and an art, and Beacon takes care of the science so the games can focus on crafting joy. That's the spirit. And AI is part of those tools. Beacon Pegaso, our suite of generative AI art tools, is part of this offering that we gave to our game teams. So they are also all powered by AWS. So they could interact with our fine-tuned models that were trained by Amazon SageMaker without our data never leaving our VPC. And I'm going to explain now what each of these tools we built are and also why we build them. We started with the Slack bot because in our company, everyone had a Slack. And our first goal, this was the first thing we did, was to democratize and learn together how to use these tools. So we wanted every people at Rovio to at least generate an image with AI and learn together. But we had a lot of adoption barriers. There were a lot of concerns. We still have a lot of concerns, and they are valid ones. For example, data privacy was one of them. Fortunately, was solved by AWS. But, for example, harmful content is still a big concern. You can generate really convincing deepfakes with this technology that can be really harmful. They are also really concerning environmental issues or also enshittification, which means that you can flood internet with crappy content. Also, IP rights issue was a really sensitive one. Back then, 3 years ago, there was this website called ArtStation, which is one the artists use to showcase their work. And a lot of base models used those images without their consent to train these base models. So they were really pissed, and they put a lot of no AI pictures in the site because they refused to take those AI-generated images down. So, as you can imagine, this is a very sensitive topic for the artists, for good reasons. And there were other concerns, like, for example, biases. And actually, building the bot helped a lot with that, because we were prompting together in public Slack channels. And one time, one product manager, she prompted a very important meeting at Rovio. And we only got white male people in the meeting room. And we are a very diverse company, and that didn't represent Rovio. But the best way to combat biases is to be aware of them. So we knew that that bias existed, and next time you want to generate a meeting room at Rovio, you put more effort on the prompting to make sure it's diverse enough. So that was one of the big wins with the Slack bot, to open the conversation. It's not about trying to convince someone that AI is good. It's about talking openly about all of these issues, and that helped a lot. And where did we build the Slack bot? We picked SageMaker. Why? Because we were already familiar with it. We had already a lot of machine learning models in SageMaker, and SageMaker also provided support for GPUs that we needed for the inference. So let's see the Slack bot in action. First, you ping beacon Pegaso, and you give it a prompt. In this case, a mystic forest clearing in our target style. Then beacon Pegaso will reply, okie dokie, I'm working on it, so you don't get nervous. But it only takes a couple seconds until you get the final result, which is the image in that style. And what we have in the back is a Lambda replying that first message. And that Lambda sends a request to SageMaker to start generating the image, which is then stored in S3. And another Lambda then sends the image generated back to Slack. All the messages are passed using SNS. And also we have a third Lambda at the end that stores some metadata into RDS that can be used for analytics, like how much time the generation took, how many generations per day, those kind of things. So okay, we had the Slack bot. People were generating a lot of images at Rovio. We were learning together. But the Slack bot was really simple. It didn't work for our artists. It was not helpful to generate content in our games. We needed something more advanced. And the good news is that there were a lot of open source tools available that provide us a lot of power and a lot of flexibility. But they are really hard to use, and they are also really computationally expensive. So we need to make it easy for our artists to experiment with the cutting-edge models and tools from the open source community. We didn't want to build some new UI ourselves or new tools ourselves, because this space changed so fast that it could become really quickly obsolete. So that's why our focus was to rely on open source projects. And we started with our local laptops. That was the fastest way, trying different projects, open source projects, trying different models, and that worked for a while. But our artists started getting very excited. We had to sit with them and configure this model on the laptops. These are non-technical people, and we had to deal with Python virtual environments, bash scripts, all those kind of things. And every time we did a new model or we had a new update to get the latest updates from the open source projects, we had to sit again with them and update everything. Some artists got even so excited that they ordered to our IT super expensive GPU desktops that got delivered to their home. And they were saying they were as loud as washing machines, but they were really fast to generate the images. But this was clearly not scalable. We had to do something. So that's why we went to the cloud. We moved all this code, all these projects into an EC2 instance and allow our artists to connect with an SSH tunnel. So we started simple. The nice thing was that we started with the G6 family, and it was a bit slower than this expensive GPU desktop that the artists had ordered at home. But then Amazon released G6E instances, and it was much faster than that expensive desktop that the artists had purchased. And they stopped using them. They just went to the cloud and used our models that we provided because it was better and easier. Okay, but this is still a bit rudimentary because we needed to still set up the SSH tunnel. We didn't have like a friendly URL that the artists could bookmark in their browser. So we need to do a bit better still. So here you can see one example of an open source tool. This is a UI that the artists interact with. So they access it through our VPN or from our offices. And there's a friendly DNS thanks to an inbound Route 53 resolver. So we have a friendly URL they can bookmark. But also behind this, we have auto-scaling groups that allow us to provision these instances across different availability zones. And this is important because there's not so many GPUs, and it's really good that if there's no a GPU available in one availability zone, you can provision it in another one. It is, of course, good also for fault tolerance purposes, and also for saving money, because as you can imagine, these GPUs are expensive. So what we do is we turn these machines off during weekends, outside working hours. But I'm talking about EC2 instances. So in there, we just made easy accessible EC2 instances, but we don't have just one, we have many. And our engineers, our AI engineers, had to create new versions of these EC2 instances to create new models, or also to fine-tune different things. So actually, it was not very flexible because all the previous architecture I showed you was in Terraform, which our AI engineers are not so comfortable with. So our goal was to make it also simple for our AI engineers to push the latest version of the open source tool or to put the latest models out there. So they would just, with what we built, push the code to Git. It goes into a Git repository, triggers an AWS code pipeline. That what it does is it spins an EC2 instance, a creator instance, that then installs in another EC2 instance all the stuff that we need. And it could be downloading the base models from S3, downloading all safe tensor fine-tune models from S3 also, and setting everything up with different scripts. And all of this is automated. And at the end, what we get is an AMI that we can use to spin new EC2 instances powered by powerful GPUs that artists can use. So we had now the Slackbot, super simple for all the company, and we had Pegaso Pro Studio Cloud for advanced users, but it was really complicated to use. So we needed something in the middle, something that allowed us to generate game content, but it was more accessible to all Rovians. And at this point, because we developed this one this year, we already had a lot of fine-tuned models. We have many, and our artists were starting to find really complicated to find which fine-tuned model should I use for my use case. So imagine we have an artist that wants to generate an art background in their style. They go to this page in our internal documentation and they find, okay, this is the one I want. They still have a bunch of workflows behind it that they need to decide which one to use. So they're still not super trivial. So we wanted to hide all this complexity away for the end users. We wanted to organize all these workflows and help them also to prompt. And that's where Amazon Bedrock and Cloud Code came to our rescue. Why? Because usually what we would have done, we would have requested resources from our other teams, like maybe front-end developers and back-end developers, and we would have needed to wait for some time because, of course, they are busy with other projects. But we had recently started playing a bit with Bedrock. So what we did was we created a new inference profile with Bedrock and connected it with Cloud Code to start vibe coding something. So 2 of our AI engineers, interns, and 1 UX designer intern, they started working together to try to create a nice UI on top of all this complexity that we had. And after a few weeks, they got something like this. So now our artists can go to this page. Imagine they are from Dreamblast. They just, on the top, click on Dreamblast, and they will just get the workflows and the use cases that are relevant for them. So imagine they go to a background use case. They will also have the prompt and the image that was used to generate the prompt. So basically, in this use case, you can start tweaking the prompt, change it if you want something different, but we also had there at the bottom Pegaso Assistant. This was really helpful because they could just text and chat with the Pegaso Assistant to modify that prompt. So they didn't need to spend hours crafting the prompt. So let's see it in action. Imagine that we want this forest now in winter with some fox around. So we ask Pegaso Assistant to generate that, And behind this Pegasus assistant, we have also Amazon Bedrock. We created a different inference profile, and the nice thing about this is that we can track cost associated with this versus the other use cases we had before with Cloud Code. So it's really easy to track cost across use cases. Also, another nice thing about Bedrock is that we could switch very easily from one model to another using the Bedrock Converse API. So, okay, so we have, in a matter of seconds, got this suggestion for the prompt. So we click in Apply Changes, and we get the result. Just in a few seconds. Even if we are not yet fully satisfied, we have some parameters there that we can still play with. We could fix the seed and keep changing the prompt to, for example, remove that nest that is in the tree. And the image will not change drastically. So this is how it all comes together. On one side, we have the AI engineer, and on the other side, we have the artist. So the AI engineer fine-tunes images in Rovio style. Then those fine-tuned models are used to generate these workflows that can be used for different use cases. And then we hook these workflows with this Pegasus Studio frontend that our artists can use to really simplify the use cases they want and generate the images. So with this, a lot of our artists that were using before Pegasus Pro Studio Cloud, they started using Pegasus Studio because it was much simpler and they could generate things way faster. They only had to go to Pegasus Pro Studio Cloud when they really had really complicated use cases that really required that extra control. And Pegasus Studio is just a frontend built on React with Cloud Code, but the backend is still our fine-tuned models and our workflows in Pegasus Pro Studio Cloud. So suddenly, in some cases, our artists could generate hundreds of illustrations per day. And I would say that's pretty extraordinary. And now, Rupert will talk about what were the benefits for our artists.
Thanks, Ignacio. That's definitely some journey. So coming back to our story where we started, what do you guys think would have happened to the artists after getting the right tool for the right people and going through this amazing journey? You guessed it right. We had a bunch of happy artists. Even though we could not get the artists here to reinvent, we managed to get some testimonials for all of you. So Tat here says that Beacon Picasso is really vital for her team since they've started using it. They're able to produce twice as much as content, which they could before using Beacon Picasso. This is giving them additional time to experiment and enable fast test-to-learn cycles. The second testimonial is from Javier, who said that Beacon Picasso helps navigate through the slow part so that they could move straight into what artists love, which is expression, character, and soul. And we have tried to summarize some of the key benefits that Rovio achieved by Beacon Picasso. The first benefit is data privacy. As Ignacio mentioned, at the beginning, data privacy was actually a big concern for Rovio. But when they started building this, they initially built all the data on-prem, and they started moving stuff to AWS. So Rovio had higher control of their data because they are fine-tuning their own data. The images were created in their own style, and all the data was fed with their own IP. All of this was possible because of AWS, as it was not able to leave their VPC at any point of time. So everything stayed within their VPC. And that's how they achieved a higher level of data privacy. The second benefit is, of course, flexibility. So I think for all the three tools, Ignacio mentioned that they had the flexibility in terms of choosing the instance type or the families. So in the specific case that he mentioned, they were initially using G6, and they moved to G6E family, and they get a lot of benefits by moving there, not just having faster GPUs, but also better price performance. Also, they had the flexibility of using Bedrock, which provided them access to more than 50 LLM models. And they could use this with managed API to access all of these diverse range. The third benefit was higher velocity. I think at the beginning I mentioned that they were able to achieve more than 80% of production time savings. And that is for the season pass background use case, where they initially used to take 20 days, and now they could achieve the same outputs in 4 days. It is important to mention here that it is not just because of GenAI that they were able to achieve the higher velocity, but by implementing AI in the process improved as well. So process is also the key here. Last, but definitely not the least, and I was told by Rovio to focus more on this benefit. More than higher velocity, I think the bigger benefit was that Rovio could now innovate. The artists had more free time, they had more time to experiment, and all of this free time could help them with more experimentation and building stuff for the future. And that is something that is resonated by Tatu, who says the same thing about AI, if used well, isn't just about saving money, and that is what you achieve by higher velocity. It is about creating something extraordinary, something that wouldn't exist without it. On that note, I want to ask Ignacio a question on what is held in the future when it comes to GenAI for Rovio.
That's a great question, and I can share that we are exploring, we are researching, because we need to be prepared for potential futures. We don't know what the future may look like. And we are researching in a lot of different areas, like, for example, 3D. We can create, for example, this crocodile in our style and turn it into 3D already. But this is not yet ready for production use in our case, but it's advancing so fast that who knows what could happen in a couple months. Another area is animations. We can turn these images and turn them into life, animate them. So this, even though it's not maybe to the quality we want it to be for in-game use, it could maybe use it for marketing purposes already. Then we are also exploring video. Here you can see one of my colleagues walking a dog. This model decomposes that image into depth, 3D pose, mask, and then we give a reference image. And again, one fine-tuned character in the style of our games, and we have the character walking the dog. Looks cool, right? And last, we keep exploring brand characters. Even though we failed, we keep doing it, and we keep failing because we want to learn. These are our last results from some months ago. They look really good to me. When I show them to our artists, they say they still find some defects in here, but they are almost there. So things are looking really promising on this area too. Because we need to really be open-minded, even though we have failed in the past. We need to be open-minded and keep trying, keep learning. Because things are changing so rapidly that you need to adapt. Because some research will make today's work obsolete. But it also will enable new use cases. So remember to adjust your path. Thank you.